TwatFS is really just elaborate performance art.
Okay, we're live. Thanks for the update, Noid. All right, I'm CP. I'm with DC949. It's a few other guys from DC949. Virus, Adam, Frank too. It's kind of hectic tonight. We're just going to be getting up and sitting down and presenting our different areas of the slides. So yeah, let's get this started. Oh, yeah, I almost forgot. Make sure not to forget this. Any questions? Just throw them out as is in real time. We'll take care of them. Just.
Has sushi been written yet?
What are you talking about?
Your talk from last LayerOne.
What are you talking about?
You really support nuking the whales?
What are you talking about? Is Don here? Yeah, so stand up, please. This guy is awesome because, like, the hardware fairy did not smile on this talk at all.
Tell them about the disaster.
We have suffered hard drive death, laptop complete failure. We couldn't find adapters, and Don just kind of said, here. And now we have a talk, so thank you. Yay. So, right. So how this happened is in Santa Monica, there's this this kind of gathering every Wednesday, started by the guy that runs Hackaday. They call it the Drink Up, and it's a bunch of hackers, and we drink on Wednesdays, and it's fun, and we talk about random crap. And one early Wednesday after work, me and CP rolled a little early, and we were. I mentioned to him one day, I'm like, "Hey man, you ever remember like news groups from back in the day?" And he was like, "No." Because he didn't use them. I was like, oh, well, I guess I'll explain it for those of you that may not know what they were. News groups were basically like the forums of the BBS era. They were like, you went onto a news group and you send your tiny blob of message, and then someone would reply to your tiny blob of message, and there were, whole long lists of blobs of messages. So somewhere along the line, people figured out, hey, if I take my file and then break it up into a bunch of pieces and then take those pieces and post them as messages, then they would stay there, and then people could read these messages and turn them back into files, and we could file share, and it was a big deal because you couldn't really do that back then, and yeah, it was cool. And then people started doing that to child porn, and they started banning it, and then they cost money, and they kind of went away. So we're talking about this, and I'm like, yeah, so Twitter's kind of like a news group, only it's not a news group. So what if we did like the file sharing crap that used to happen over NNTP over Twitter? And he was like, And then we went home, and around 1 in the morning on Thursday, like maybe 3 hours before I have to wake up and go to work, he calls me and goes, so it's done. I'm like, what's done? He's like, that thing we were talking about at the Drink Up, it's done. I'm like, what? Okay, that's cool. What, you use base 64s? That way it was in the ASCII key space and like gzip compression or something? He was like, yeah. I'm like, okay, cool. That sounds really inefficient. And he's like, it is. I tried to post the Hackers Manifesto, and it was like 60 tweets. I'm like, oh, okay, well, I'll Google it and figure out if we can make this better somehow. So I go to work, and, around lunchtime I get bored, so I start Googling around, ways to do, ASCII compression or some crap. And lo and behold, like 2 days before we were talking about this thing on Wednesday, like on Monday or whatever, this guy named Anura Sativ, I guess is how you say his name. He's Indian. I don't know. When we publish the slides, you can copy it there. Had posted on his blog that, like 2 days before, saying, so I hate Twitter, and I got rid of my account that I had for a year. But I had this idea. Twitter uses UTF-8. So it would be cool if someone could take, data and express it as UTF-8 using this encoding scheme, which we'll cover later. And you would get, he hypothesized getting somewhere close to 420 ASCII characters per, like, tweet instead of 140, based on the, Yeah, exactly. Based on his math. And I was like, yeah, I found this. This might work. Let's try that. Okay. So then I had a engagement. By now it's Friday, and I had something to do that weekend. So I was kind of away for a couple days. And on Sunday, he calls me and goes, "Yeah, so we had like Hack Weekend this weekend, and like it works." I'm like, "What works?" "That thing you found online. It works. We like did it." I'm like, Oh, oh, that's cool. And then by then it spiraled out of control, and I went over and we kind of, consumed our lives for a few weeks. And yeah, now we have this, UTF-8 expression method for data on Twitter, and it's kind of funny. And now we're gonna talk about it. So that's what happened. Who's next?
So, after we left the drink up, I took Virus home and started cracking on the project. Initially, obviously, we can't just post binary data to Twitter. It's not compatible. So I had to think of a way to, encode the data, and Base64 seemed like an obvious choice. It wasn't exactly efficient. It increased the data size by like 33%. It took a lot of tweets, a lot of chunks, we call them now, a lot of chunks to make a single file, even small files. Even with BZ2 and gzip, it still needed a lot of work. So we, and then as Virus was saying, we moved into UTF-8 smuggling, which turned out to be really, really interesting. And that was a really short amount of time. I know. This is not working out, guys. Just relax.
All right, so Virus tells CP about this UTF-8 encoding, and CP tells me, hey, we can probably get 3 or 4 times as much data in each tweet as we're doing right now. So I think, UTF-8, that's that Asian character set thing. Yeah, I've used that before. Sure, I can do that. So I look it up, and UTF-8 is it's similar to ASCII, and it's backwards compatible. But instead of getting just a normal 127 different characters, you're going to get up to, it's about 1.2 million different combinations. So you can fit a lot more data into one character than with ASCII. It's a variable number of bytes. So if you have a large character that's used in a kanji or something like that, it might be 2 bytes. If you get one of the more rare ones, it'll be 3, and it can actually go up to 4. And the way you know how many bytes are in each character is by the bit pattern of the first byte. So, and I'll get to that in the next slide. But it can encode anywhere from Unicode 0000 through 10FFFF, which, like I said, is about 1.2 million. And if you want to see the actual RFC, it's 3629. And here's the technical data of what the encoding scheme looks like. As you can see, the first level is just a 7-bit character. That's any ASCII character will drop right in there. If it's something bigger than an ASCII character, you just break it down based on how many bits it is. If it's 11 bits, it'll fit in 2 bytes. 16 will be 3 bytes, and anything larger than that will be 4. And there's a star next to the 21-bit character because not all 21 bits can be in any position. For example, the first byte needs to be F1 or F0 through F4, and it can be anywhere in there. If it's F5, F6, and up, it's not considered a valid UTF-8 character. So I went through all this and figured out, okay, these are the bits we want to use. We're going to go with just make all of our UTF characters 4 bytes long, and that should take care of that. And then we had Frank 2 come over and help us out with encoding and getting that Base64 data into these UTF-8 characters.
All right. So the reason Base64 is called Base64 is because there is a 64-bit key space. The way it's encoded is that it basically you take an 8-bit number and then you transpose these 6 bits and then these 6 bits and then these 6 bits and then you get a Base64 encoded character. And the way they do that is using the printable ASCII space in order to put data in a method in such a way that it's ASCII encoded. So if we consider the last slide, in which, let's look at this. If we consider the last slide, you'll notice in the 4-byte area, there are 6 bits we can use, which is totally perfect for Base64. So basically, what we decided to do was, is that the right slide? That is the right slide. So what we basically decided to do was say, hey, we've got this 6-bit character. why don't we put this 6-bit character into each of those values and just set the first one to, I don't know, a random number between F0 and F3, because that should be a valid UTF-8 character. And from here, we determined that we were able to encode 18 bits. Yeah, that's the right math. We were able to encode 18 bits into each Unicode character. And in turn, we were able to push, well, I can't do the math on the fly here, but this is basically the amount of data we were able to push up. So if you have a calculator on your iPhones, you may want to try that out. But then we realized, why are we even doing base 64 in general? Because it's taking off 2 bits when it's encoding. It's increasing the size of whatever we're encoding it to. So if we take some bzip2 data or some gzip data or any binary data for that matter, we're going to increase the size by quite a bit because we're losing 2 bits with every encode. So we decided, hey, why don't we just encode it directly to the binary? And we started out with a method that was similar to the naive encoding method that what it did was it took the binary data and just completely skipped the base 64 method. But as we did more and more research, we realized, hey, Twitter doesn't like a lot of the characters that we're putting to it, and it's corrupting a lot of the data. So we decided, Adam came up with an idea to actually put all 20 bits into each UTF-8 character. And the way this works is we read 20 bits from either a data stream or a string stream, and we turn that into a number. And after we turn that into a number, we realize, okay, how big is this number? If the number is less than 128, we just encode it as a 1-byte UTF-8 character, and on decode, we pad it with all the zeros that weren't there in the original encode. If we have a 2-byte character, for example, or if we have a character bigger than 2048, it can encode it into a 2-byte UTF-8 character, 3 bytes and 4 bytes, and so on and so on. So here is the chart to give you an idea. It's the same chart as earlier. But this is the range. On the left-hand column, we have the range that encodes into that certain byte. So if we have a number between the values of 0 and 127 after reading our 20 bits, we encode it into a 1-byte UTF-8 character, which is basically the ASCII range between 0 and 127 anyway. If the number is between 128 and 2047, then we encode it into a 2-byte character, et cetera, et cetera. And Adam, would you like to explain the data compression? Yeah. Comparison.
So I was really interested in how much gain we've made since our first version. So I went through the numbers and just pounded them out. Everything I did is after compression because what your input file compresses to depends on what type of file it is. But after compression, everything's going to be constant. So with the base 64 method, 2K file, after it was compressed, would be 2,700 characters of base 64. And since we were just putting the base 64 into Twitter as ASCII, it would take 231 characters. And since we only get 140 per tweet, that's why it was taking up so many messages. After we started putting that base 64 data into the UTF-8, it cut it down by 3 because we still had the same number of base 64 encoded characters, but we could fit 3 of them per UTF-8 character, so we only had 911 characters to post to Twitter. Once we got the pure UTF-8 encoding working, we actually had an intermediate step where we were doing 19 bits because that top bit, the top bit was causing some issues. So the best case scenario, it'd take 820 UTF-8 characters to get that 2K of data, and the worst case scenario is 861. I'm happy to say that a couple hours ago we finished that up, and now it's always going to be 820 for every 2K of data. So it's a pretty simple calculation. What about the restrictions, CP?
Oh, I love this musical chairs. Okay. During our research into this application, we kept bumping into the rate limiting and IP limiting that Twitter enforces, which is about 100 tweets an hour, and some, I think, per hour per IP, unless you have a whitelisted account. But long story short, I emailed Twitter and I explained a little bit about what we were doing, and essentially said we're storing very, very small files in your on your service, and we'd like a whitelisted account to continue our research. 6 hours later, they said, okay, and they said, good luck with your research. So if they ever say that we're abusing their system, I feel I have consent. Yeah, 20,000 per hour for a whitelisted account. Never really going to bump into that limit, but it's nice to have a nice giant toy to play with. As far as the IP restriction go, it doesn't really matter if you have a whitelisted username. Yeah, let's do the. You can do it for your the one account, but I could have given them an IP address as well, but I didn't. I just did the one account. You can email. I forget the email, but you can find it on their website and contact them about getting a whitelisted account for any reason necessary. Frankie, do you want to set up the demo? Yeah, sure. Give me the mic. No. Yes. There we go. Yes. So we're going to do a little demonstration, and everyone
Incite the rage of Strom Carlson.
Everyone can get a distribution CD if you would like. This all has the source code and stuff on it. I don't even know what you were doing. What? Gee, thanks. So, no one? Okay. All right, well, come and get it. I'm waiting.
The display got mirrored? How did that
So what you're going to need to do...
Hang on, Apple is failing.
Well, let me just walk them through it. Basically, on this disk contains... On this disk contains some basic Python files and download.py, which is a restricted version, a very limited version of the actual proof of concept. So what we're all going to do when we have internet, which is not right now, which we weren't depending on, is hoping we'd have a network up so we could all play with this together.
We're using that cool guy's cell phone for internet, actually.
Can you bridge the
Is it
Wi-Fi
off?
card?
No, yeah, I know. This guy, I meant. Not you. I'm sorry.
All right. You're going to want to move the files off the CD into a writable directory. And when you run download.py, it's going to download TwatFS via TwatFS.
Yo, dog.
So you're going to download the source code via the proof of concept application. And in there is going to have twatfs.py, which you can modify to contain your authentication, username, and password, and upload and download your own files. Frank 2?
All right, so as you can see here on my thumb drive here, the files I have are just some stripped down versions of what we have. And if we look at the download code here, all we really have here is just a stripped down downloader of the original code. And what we're going to do is just run the download script, and it should download twatfs.py. And actually a few other things, such as a picture and perhaps a text file. So if the live demo gods don't hate me, this should run just fine. Here we go. Yeah, I'm going to get pelted, aren't I?
Yeah,
Come
it doesn't look
Internet.
like it's working through. Is the network card on?
Is it really? Well,
Yeah.
it's going through the phone. Where's my mouse? Hang on. Let's test the internet, too. That would be a good idea.
I swore I did nothing to break it.
Hey, the internet works. So, whoa! Not what I wanted to do. No. All right, maybe if we look over here. Oh, of course it failed. Live demo has failed. Well, I think that might be because, what is that error? Oh, yeah, that's because the internet was slow, apparently. So now that I know the internet is working again, let me try running it one more time.
Personally, I blame Al Gore.
You got us all into this mess.
My email is clogging up your tubes.
Yeah.
Pretty much. He is emperor of the movie.
I'm going to not intend you to use Twitter this way.
Apparently.
Try running just the regular TwatFS application to download. Oh, okay.
All right. I'm not sure if it's the downloader so much as the actual. Yeah. All right, let's try one more. Oh, that's not even canceling. I don't think so.
It's an eco whale? Yeah.
Everything's done. We don't have the original. We only have the downloader.
TwatFS.py, that's what I gave you. That's what you should have.
No, I just have the downloader there. I don't have it on my thumb drive. That's the issue.
Fantastic.
Whoa, look at all that internet problems. Yeah, this is not going to work, but it should work on your CDs. Yep, there it is. Any more? All right. Any more?
You guys can't aim for crap.
Yeah. Come on, you got to have more. There we go. Thank you. Yeah.
Oh, here we go.
All right, come on, come on. It's point blank.
Moving on.
All right, so let's move back to the presentation now. You hit my. How did you hit my foot? So, CP, would you like to explain Unstoppable?
You know, I was expecting the demo to fail on some sort of level, but that was, I'm sorry. Yeah. Yeah, so what can Twitter do to stop TwatFS? I mean, even if they'd want to. I mean, I don't know. It's not exactly an abuse of their system. I have consent, by the way. Now, right now, each file timeline is wrapped in header chunks, which contain meta information about the file name, the encoding type, and a few other small details. I suppose they could block tweets containing those headers, but we could just change those headers. You're going to block the accounts that use the application. We just make new ones. They're free. And that last one, I mean, I don't even know. Develop detection algorithms that analyze your incoming tweets. They can't even keep their servers up in the middle of the day, so I really don't think they're going to be wasting cycles on fixing this. I mean, they can't even implement SSL properly, so I really doubt that's going to happen. They really don't want to disable support for UTF-8 because they're really big in Japan. They're moving into new territories. It's just not an option. And
That would work if they went directly to the database for every tweet before they propagated it, which is...
Well, they can propagate it once and then you remove it from the line.
Yeah, but if it's propagated, then it's already out there.
right, but then they could just remove it. I mean, once it's out, but then they could just remove it, so it's out for a little bit of time. One way we thought about it, they could develop an algorithm that could detect if you have maybe 5 or 6 different languages of characters in one file, or in one tweet rather. Because there's really no reason anyone would ever tweet in every character being a different language.
There's also no reason for you to tweet mahjong tiles, which are apparently in UTF-8.
It's true.
And as far as making more restrictions, people, I mean, non-developers are bumping into the 100 tweets per hour limit. These people have no lives. But it happens. Much less us hackers, but, you know, I don't even know. Yeah, so there's really, I mean, they can do some things, but when it comes right down to it, they can't do it without alienating a lot of their users.
Well, given the demo failure, can we at least try to see the Twitter stream?
Yeah, let me pull that up.
If the internet works.
How do I,
If the internet works. Because if the internet works, then we would have been able to do the demo.
Where's the air card? No, his air card. Yeah, it's his work card. Yeah, I know. I'm trying to pull up Firefox. Here, do you want to take care of it?
Yeah, I'll try to get this internet thing working. Oh, this won't install once.
I thought it already has the internet on it.
That was on my computer. Yeah. All right, let's see here. Where is that pesky Safari or Firefox? There we go. Okay. Oh, Safari is already loaded. That was a stupid mistake. Here we go. Hey, internet. All right. Don't fail me now, internet. It's TwatFS files, right?
Yeah.
.com, TwatFS. Oh.
Yeah, 2 dots.
Whoa. That's embarrassing. All right. Hey, it's loading. Perfect. So now at least we'll be able to see what the stream looks like. Check that
God
out.
bless the Christians for supplying us with Scott balls.
That is the Hacker's Manifesto right there, which Didn't work. A guy with a hat. Keep on scrolling. A few more tweets. Hang on. Let's check out what the TwatFS zip file looks like. Yeah. Sometimes you can, if you actually view the source code, there's actually stuff here. But Twitter's just pull up the RSS feed. Okay. Oh, it's gonna. It might ask for my login now.
No, it's not. It's a public timeline.
I think you just subscribed him to TwatFS files. We're breaking things. We should just go back to talking. Apparently, that's all we're good at. All right. I'm not okay.
If you question, you're just stretching.
The RSS. What? Yeah, this link that I clicked. Oh, by the URL.
Go ahead.
Shut up.
Oh, shh. I'm blind. I'm
Hey.
sorry.
Stop talking. We have a question.
Hey,
I'm just going to go
Thank
back
you.
to the presentation.
Oh my God.
did you guys see earlier this week there was another person working along the same sort of vein?
Mona tweeted too?
Yeah.
Was it? Yeah.
Yeah.
What's cool? His UTF-8 library only allows him to smuggle like 230 bits
It was
per
he
chunk, and we have,
basically like
350
moved it
bits.
from from
Bytes.
140 tweets to 200 or not 140 tweets, 140 bytes to 280 bytes. He only doubled it.
Right, and we have 350 bytes right
Yeah.
now.
Something like it's yeah, something like that. So,
Also, his method to getting to the final product used an approximation algorithm. So what you get
you already
left
finish this
with
slide?
is a rough image of the file. This is the exact file. Who else is susceptible? So this is nifty, but you know it works on every site. There's no reason it only has to work on Twitter. The only real major bonus to it being on Twitter, aside from the fact that a bunch of people use it, is Twitter pushes to cell phones. Most social networking systems don't do that. So it's possible for you to do things like write cell phone applications that'll just read off the GPRS stream without getting online and download files. Potential for malicious activity, who knows? But yeah, from, you know, pick your number Chan to MySpace to Facebook to anything with a form, this works. Any place that, you know, will accept UTF-8 is susceptible. And there are a bunch of potential uses. Pretty much the week after we finished the like horribly alpha version, which is apparently still horribly alpha, of the client, I kind of called a few people and was like, hey, guess what we did over the weekend? And the response was always, oh yeah, we did some Twitter stuff too. And people had thrown all kinds of ideas, from posting pictures to, you know, posting torrent files on different streams and using each stream as a download queue instead of using a torrent client, from using it as a torrent tracker so that your requests for which bytes you want go to a Twitter stream. That way, you know, the RAA and people won't be able to live track it unless they're members. Anything involving really small files, it's a way to get stuff around. Like social bookmarking, you know, taking little file snippets from different blogs and moving them around. Crypto stuff, you know, subscribing to a tweet and having that be the second factor in a two-factor authentication scheme, you know, RSA style kind of stuff. Payload delivery for like bots, or, you know, I mean, if you have a botnet that infects a bunch, you know, say you crack TweetDeck, right, and your bot goes everywhere and infects a bunch of people, and then it decides it wants to download its evil malicious payload. Well, how are you going to get that around? Well, if it can just read the data off of a Twitter stream, what are you going to do? Block Twitter from TweetDeck? Yeah, there's a bunch of stuff. It's fun to theorize, but we shall see what people come up with. We're done. If there are questions we have missed, these are our Twitter accounts over here. Or you can email questions.
any questions?
Any more evil balls of death?
Yeah, you had to expect this question. I already asked it, but is there going to be a mountable version of TwatFS?
Hopefully, yes.
I definitely plan on writing a FuseFS plugin and employing the help of others in order to do it. Because, I mean, come on, you're reading and writing so slowly, but you're doing it over Twitter. How funny is that? That's just perfect.
So what other kind of things have you guys found when, you know, doing research on Twitter?
The RSS feed. Let me explain this. The RSS feed.
That is insider trading with questions. You can't do that.
The RSS feed seems to kind of barf on single byte UTF-8 encoding. One of the ways we encode the data is after doing all the UTF-8 encoding, we're going to run into the last byte, which is probably not going to have all 20 bits set. So we append a number that just represents how many bits are there. And when you view that stream on Twitter, it shows up as 7, which is absolutely what it's supposed to be. When you view it in the RSS feed, it's an asterisk, which is not 7. It's something like 42. And that's way out there. So there are various problems in decoding from the RSS feed that don't show up on the Twitter page itself. So that is one problem that's very interesting, and I have no idea why it does that. But we have workarounds.
Any theories for why?
No. I wish I knew.
Have you contacted Twitter to find out yet?
No, but that is a good next step.
Well,
Sounds
it's
like
written
Web
in Ruby,
2.0.
so words like robust should not be used.
Don't give it back this time.
Are we done? I think we're done.
Any more questions?
All right, well, we had a lot of fun screwing around with Twitter.
Yeah.
Goodbye.
Thank you very much.